Let's look at the negative binomial distribution. The worst free throw shooter in NBA history is Ben Wallace, who made only 41.4% of his free throw attempts. Suppose Ben starts shooting free throws. Find the probability that his first successful free throw comes on his third attempt. Well, let x equal the number of the attempt on which he gets his first success. As we have seen, x has a geometric distribution. The p.d.f is f of x equals 1 minus p to the x minus 1 times p. The mean of x is mu equals 1 over p, and the variance is sigma squared equals 1 minus p over p squared. The probability that x equals 3 is, in other words, f of 3. That's 1 minus p to the x minus 1 times p. That's 1 minus 0.414 to the 3 minus 1 times 0.414. In other words, it's 0.586 squared times 0.414, which is 0.14217. And this seems reasonable. It's the probability of 2 failures. Here's the probability of failure times the probability of 1 success. There's the probability of 1 success. Find the probability that Ben Wallace's 10th successful free throw comes in his 13th attempt. Okay, let x equal the number of the attempt on which he gets his 10th success. Then x has what we call a negative binomial distribution. More generally, if x is the number of the attempt on which he gets his rth success, then x has a negative binomial distribution with p.d.f, f of x equals x minus 1, choose r minus 1, times p to the r times 1 minus p to the x minus r. If we want to find the probability that his 10th successful free throw comes on his 13th attempt, then r is the number of successes, that's 10, x is the number of trials, that's 13, and p is the probability of success in one trial, which is 0.414. So there's the formula for f of x. F of 13 is going to be 13 minus 1. Choose 10 minus 1. 13, again, is the number of trials. 10 is the number of successes. Times p to the r. P is the probability of success in one trial, so that's 0.414 to the 10th. Times 1 minus 0.414 to the 13 minus 10. In other words, the probability of a failure, which is 0.586. So we end up with 12 choose 9 times 0.414 to the 10th times 0.586 cubed. So again, this is the probability of success. That's the probability of the probability of failure. And we end up with 220 times 0.0014, etc. In other words, we end up with 0.006548. Here's why the answer is 12 choose 9, 0.414 to the 10th, 0.586 cubed. One way to get your 10th success on your 13th attempt is to start with 9 successes, then get a string of 3 consecutive failures, and then get a success. The probability of starting with 9 successes, then getting a string of 3 consecutive failures, and then getting a success is p to the 9th, that's your 9 successes, 1 minus p cubed, that's your 3 failures, times p, so that's your success. In other words, it's p to the 9th, 1 minus p to the 3. However, there are other ways to get your 10th success on your 13th attempt. All you have to do is get exactly 9 successes in your first 12 attempts. The number of ways to distribute 9 successes among your first 12 attempts is 12 choose 9. Each of these ways occurs with probability p to the 9th times 1 minus p cubed, so the probability of getting 9 successes in your first 12 attempts and then getting a success, in other words, the probability of getting your 10th success on your 13th attempt, is 12 choose 9 times 0.414 to the 10th times 0.586 cubed, which is the p.d.f for f of x. Find the probability that Ben Wallace's 11th successful free throw comes on his 23rd attempt. Well, let x be the number of the attempt on which he gets his 11th success. Then x has a negative binomial distribution. R, that's the number of successes, that's 11. X is the number of trials, that's 23. Probability of success is p equals 0.414. F of x is x minus 1, choose r minus 1, times p to the r times 1 minus p to the x minus r. So f of 23 will be 23 minus 1, choose 11 minus 1, times 0.414 to the 11th, times 1 minus 0.414 to the 23 minus 11. In other words, it's 22 choose 10 times 0.414 to the 11th times 0.586 to the 12th. In other words, it's 0.0649. On average, his 11th success occurs on which free throw? The mean is mu, that's r times 1 over p, That's 11 times 1 over 0.414, which is 26.57. That's on average his 27th attempt. Oh, let's switch to football. The most accurate kicker in NFL history is Dallas Cowboys kicker Dan Bailey. In his career, he has made 90.6 of his attempted field goals. That's 144 out of 159. And he has never missed an extra point. He's made 204 out of 204. Find the probability that his fourth field goal comes on his fifth attempt. Let x equal the number of the attempt on which he gets his fourth success. Then x has a negative binomial distribution. R is the number of successes. X is the number of trials. That's 5. P is the probability of success on one trial. That's 0.906. F of x we've seen before, so f of 4 is 5 minus 1. Choose 4 minus 1. That's in other words x minus 1, choose r minus 1, times p to the r, which 0.906 to the fourth, times 1 minus p to the x minus r, which is 1 minus 0.906 to the 5 minus 4. That's 4, choose 3, times 0.906 to the fourth, times 0.094 to the first, which is 0.2533. Okay, now we're ready for an actuarial problem. This is from the 2015 Sample Exam P, problem 140. Each time a hurricane arrives, a new home has a 0.4 probability of experiencing damage. The occurrences of damage in different hurricanes are mutually independent. Calculate the mode of the number of hurricanes it takes for the home to experience damage from 2 hurricanes. Let x be the number of the hurricane on which the home experiences damage for the second time. Okay, now we're not talking about the first time, the second time. Then x must have a negative binomial distribution. R is the number of successes, that's 2. X is the number of trials. P is the probability of success on one trial, if indeed being struck by a hurricane is a success, and that would be 0.4. F of x we've seen before, so f of x is going to be x minus 1. Choose 2 minus 1. 2 is the number of, quote, successes, times 0.4 to the 2. 0.4 is the probability of success on a trial, times 1 minus 0.4 to the x minus 2. So that ends up being x minus 1, choose 1, times 0.4 squared times 1 minus 0.4 to the x minus 2. In other words, it's going to be x minus 1 choose 1 times 0.16 times 0.6 to the x minus 2. We can simply make a chart. Okay, x is the number of the hurricane, and on the right side we have the p.d.f, f of x. So f of 2, for example, is going to be x minus 1 choose 1 times 0.16 times 0.6 to the x minus 2. Since x equals 2, in other words, it's 1 choose 1 times 0.16 times 0.6 to the 2 minus 2. We end up with 0.16. When x is 3, the probability of, the probability that occurs in a third hurricane is 0.192. X is 4. F of 4 is 0.1728. F of 5 is 0.13824. And f of 6, that's 0.10368. Okay, x equals 3 is most likely. Notice this is the mode. It's higher than any of the others, so the answer is B.